In this lesson, we will discuss various detergents. Detergent fall into two main groups, soapy detergent and soapless detergents. Soaps or soapy detergent. Soaps are sodium or potassium salts of long-chained alkanoic acids or fatty acids such as octadecanoic acid or stearic acid. The video clip below shows the laboratory preparation of soap. Observe what happens carefully. Proceed.
The video clip below shows preparation of soapless detergents. Procedure: place about 10 cubic centimeters of olive oil in a small beaker and stand the beaker in a large trough with ice cold water. While stirring with a glass rod, add conch sulfuric acid carefully from a dropping funnel. Stop adding the acid when the yellow oil turns uniformly brown. Add 20 centimeter cubic of 4 molar sodium hydroxide solution to neutralize. Check whether lather is formed with the salt formed using tap water. Check whether lather is formed with the salt formed using distilled water.
Lather forms readily when warm distilled water is added to the soap, followed by the warm tap water. Warm river water does not form lather, but it forms a scum with soap. The white filtered solid is soap since it formed lather with warm distilled water. When an alkali is boiled with a fat or an oil, a hydrolysis reaction takes place according to the following equation. When the hydrolysis reaction takes place in presence of sodium hydroxide, the process is referred to as saponification. The sodium salt of the acid is known as soap if the number of carbon atoms per molecule is more than 8. Sodium chloride is added to separate the soap from glycerol in a process known as salting out. The soap formed in the above experiment did not form lather with warm river water. This is due to the fact that Some river water contains a high proportion hard water, hence forming scum. Soap molecules have two dissimilar ends, a hydrocarbon chain end, which is nonpolar and has no attraction for water, a carboxylate end, which is polar and is attracted to water. The nonpolar end is oil-soluble, while the polar end is water-soluble. Oil and water do not mix, they are immiscible. When oil is shaken with water, the particles of oil soon coalesce and float on the water surface. Let the soap anion be represented as a matchstick structure with a long hydrocarbon chain, which is nonpolar or hydrophobic water-hating, and a polar head or hydrophilic water-loving. The head of the soap moving to the water and the tail remaining is being attracted to the oil. When the mixture is thoroughly shaken, the soap anions surround each drop of oil as shown below. Each oil drop has a large cloud of negative charge around it. Remember, the polar head is negatively charged. The oil drops, therefore, repel each other, and this prevents the drop from coalescing. When the washing process is taking place, the soap and ions C17H35 COO become oriented on the surface of a small droplet of oily greasy dirt. The water-soluble groups on the surface of the droplets keep the droplets suspended or emulsified in the water. During rinsing, the water carries away the oil droplets. Note that the cleansing agent is water. Ordinary soap only helps the water to clean. The mode of action of soapless detergent is the same as that of soapy detergent. The hydrocarbon tail, which is grease-loving, will dissolve in fats, grease or oil, while the ionic head, which is water-loving, dissolves readily in water. The advantage soapless detergent have over soap is that they are not affected by hard water since the corresponding calcium and magnesium salts are soluble. Ordinary soap forms insoluble salts with cations present in hard water, forming scum as shown in the following equations. The video clip below shows how a soapless detergent can be prepared in the laboratory. Click to play the video and observe what happens carefully.
The video clip below shows preparation of soapless detergents. Procedure: place about 10 cubic centimeters of olive oil in a small beaker and stand the beaker in a large trough with ice cold water. While stirring with a glass rod, add conch sulfuric acid carefully from a dropping funnel. Stop adding the acid when the yellow oil turns uniformly brown. Add 20 centimeter cubic of 4 molar sodium hydroxide solution to neutralize. Check whether lather is formed with the salt formed using tap water. Check whether lather is formed with the salt formed using distilled water.
The soapless detergent in this experiment both form lather with tap water and distilled water, since the corresponding calcium and magnesium salts are soluble. Olive oil reacts with concentrated sulfuric acid to form alkyl hydrogen sulfate as shown below in the following equations. Sodium hydroxide is added to the alkyl hydrogen sulfate to neutralize it to form sodium alkyl sulfate, which is a detergent, and lather equally well with both tap water and distilled water as shown. Soapless detergent can also be made from alcohol as shown in the equations below. Step 1. The alcohol is reacted with sulfuric acid to form alkyl hydrogen sulfate as shown. Step 2. The alkyl hydrogen sulfate is neutralized by sodium hydroxide to form the soapless detergent, sodium alkyl sulfate as shown. Note that soapless detergent with a branched chain alkyl group are not easily broken down by bacteria or non-biodegradable and are therefore the cause of frothing in sewage plants and rivers. This disadvantage may be avoided by making the detergent from alkyl benzene with straight chain alkyl groups.